In day 3 of chapter 12, we're going to start talking about segments inside of circles. And the first type of segment that we're going to talk about in a circle is segments that are called chord segments. Now, just to remind you, a chord is a segment that has both of its endpoints on the circle. And when we're calculating lengths in chord segments, the pattern that we look for is this. We take the first part of one segment, one chord segment, times the second part will equal the first part of the other chord segment times the second part of that other one. So actually the pattern we think about is first part times second part equals first part times second part. So in the problem that we're doing right here, this first example, if we consider this to be our first segment, A to B, the two parts are really the x and the 6. So we have 6 times x. And then the second chord segment would be this one right here. And the two parts on that one are the 3 and the 4. So 3 times 4. So that would be how we set up this problem to solve it. And then, of course, we still have to go ahead and solve it. We would have 6x equals 12. So x would be 2 in this problem. So on chord segments, it is always first part times second part equals first part times second part. Let's take a look at another example. Okay, here we have a second example, and on this second example, again, let's consider this as our first segment. The pattern that we're going to follow, of course, is that first part times second part on the first chord equals first part times second part on that second chord. So let's get started. On the first chord, we have the 6 and the x, so that would be 6x. On the second chord, we have 4 and 15, so we would take 4 times 15. Oh, sorry about that. And then we do have to solve it, so let's go ahead and finish it. That will give us 6x equals 4 times 15 is 60. We divide, x is 10. Second example, done. Let's try yet another one. Here we have two chord segments again. So once again, we're going to follow that same pattern. First part times second part equals first part times second part. And when we look at it, let's consider this vertical one to be our first segment. So we would have 12 times x plus 2 equals, and then on the other one, we would have 24 times 24. And now we're going to go ahead and finish it. Well, we'd have to distribute on this left side. 12 times x, 12x. 12 times 2 is 24. On the right side, 24 times 24 is 576. We'll subtract 24 on both sides. We get 552. We'll divide by 12 and we get x equals 46. So whenever we have chord segments, we take first part of one times second part equals first part of the other times second part of that. Let's move on to a second type of segment. And this second type of segment we're going to talk about is called a secant segment. Recall that a secant is a line that intersects a circle at 2 points. So for a secant segment, we're talking about just a part of that line. Now, when you have a secant segment, you're going to have what's called the outside part, and then you're going to have what's called the whole length. And the pattern that we follow with secant segments is The outside part of one times the whole length of that same one is equal to the outside part of the other times the whole length of that other one. So the pattern that we follow is really outside times whole length must equal outside times whole length. And when you do secant segment problems, I would encourage you to always first label the whole length. And by that I mean this. If we look at this segment right here, the whole length there from R all the way to P would be the 12 plus the 2, so the whole length would be 14. On the bottom segment, this one down here, the whole length would be when I add those together, which would really be x plus 3. So when I follow the outside times whole length, let's do the blue one first. The outside of the blue one is 2, that's the outside. And the whole length of the blue one, we came up with 14, so that's the whole length. And now on the yellow one, the outside is our x, and our whole length would be x plus 3. And that's the setup, and that's what we would have to solve. Let's go ahead and solve that. It's going to require a little bit of algebra. Now, 2 times 14 is just 28. But on the right side, when we distribute the x, we'll get x squared plus 3x. That's a quadratic equation. Since it's a quadratic equation, we're going to get 0 on one side, and then we're going to try to factor it. So I'm going to subtract the 28, and that gives us this. And now we're going to factor. We reviewed factoring in that first week. So when I go to factor it, this is what we call a general trinomial. 2 sets of parentheses. X times x will give us our x squared. The back 2 must multiply to give me 28 and subtract to give me 3. So I'll have to use 4 and 7. To end up with a positive 3, I need a positive 7 and a negative 4. And now to finish solving, I have to set each of those equal to 0. When I solve that first one, I end up with x equals 4. When I solve the last one, I end up with x equals negative 7. Now, the negative 7 won't work here. And the reason that one won't work in this problem is because we can't have negative lengths. So then we would box the 4. And once again, in this chapter, you absolutely must box your answers. Okay? Let's try another of these secant segment problems. So here we have another secant segment problem. And as I mentioned when we did that first example of these, I would suggest that you first label the whole length. So on this blue one right here, the one I'm highlighting in blue, we need that whole length. That whole length will be the 7.5 plus the 4.5, which comes out to be 12, I believe. On the other one, this secant segment, the one I'm highlighting in green here, we'll need that whole length as well. That whole length will be when we add the x plus the 5. So that's our whole length up there. And the pattern that we follow is the outside times the whole length will equal the outside times the whole length. So let's begin with that light blue one, the one we've highlighted in light blue. The outside is 7.5, and the whole length we determined to be 12. On the green one, the outside was 5, and the whole length we determined to be x plus 5. And now comes our algebra. 7.5 times 12 works out to be 90. we have to distribute the 5x plus 25. Now this one is not a quadratic equation, so we're just going to try to get the x by itself. We'll subtract 25 on both sides. 65 equals 5x. We'll divide by 5. We end up with x equals 13. Or if you prefer, x equals 13. And that's our answer. Now, in addition to the chord segments we talked about at the beginning and the secant segments, there's one other type of segment that we're going to talk about today, and that's called a tangent segment. A tangent segment, of course, since it's tangent, it only touches the circle at one point. We know for the secant segment, the bottom one in pink, we'll take the outside times the whole length, but for a secant segment, the outside and the whole length are really the same thing. So for a tangent segment, the outside and the whole length are the same thing. So for a tangent segment, we really just end up taking outside times outside. So let me show that to you one more time because it can be confusing. For the secant segment, we take outside times whole length. But then for the tangent segment, the outside and the whole length are the same, so we end up taking outside times outside. Let's do the secant segment part first. This blue one is the secant segment. As we did on the two previous problems, I think it's helpful to label the whole length. So the whole length on this one will be x plus 20. For that secant segment then, the outside is 20 and the whole length is x plus 20. Now for the tangent segment is this one here in yellow. For the tangent segment, you'll see that the outside and the whole length are actually the same thing. So we'll have to take the 31 times the 31. And that's the setup for this problem. Now on the left side, there's a little bit of algebra. There's distributing to do. So we have 20x plus 400 is 20 times 20. On the right side, 31 times 31 is 961. We'll subtract the 400 on both sides. We get 561. We divide by the 20. We find out that x is 28.05. So for a tangent segment, you have to take outside times outside, since the outside is really the whole length. Let's try one more of this type. So here we have the secant segment, and we have the tangent segment. Oh, no, I take that back. Here we have two secant segments. Since they're secant segments, we're going to take outside times whole length equals outside times whole length. And as I've said multiple times, I think it's helpful for us to label the whole length. So the whole length on this one is going to be x plus 10. The whole length on this one, the green one, is going to be 5 plus 3, which is 8. And then when we go ahead and put that into our pattern, on the blue one, the one I highlighted first, the outside is x, and the whole length was x plus 10. For the green one, the outside is 3, and the whole length was 8. And now comes our algebra. We once again have to distribute x squared plus 10x equals 24. This is a quadratic equation, so we have to get 0 on one side. X squared plus 10x minus 24 equals 0. Once again, we're going to use factoring. We reviewed that again at the beginning of this chapter 12. I need an x in the front. The back ones have to multiply to give me 24 and subtract to give me 10. Looks like I'll have to use a 2 and a 12. To get a positive 10, I'll need a positive on the 12, and I'll need a negative on the 2. I set each of those factors equal to 0. The first one will solve and give me 2. The second one will solve and give me negative 12. Now this one does not work in this problem, so we don't box it, but we absolutely must box our answers. Or it is wrong. Now it's because otherwise we would have to assume you mean none of them work. Let's take a look at another type of problem that we've actually seen before in here. When you look at this one, since we have a tangent and a radius, we know that we have a right angle down here. And since we have a right angle, we're going to use the Pythagorean Theorem. Now, of course, we're going to need this whole length for the hypotenuse. The hypotenuse there will be x plus 9. So that x plus 9 squared will equal x squared plus 15 squared. Now, we reviewed how to square x plus 9. It really means x plus 9 times x plus 9. On the other side, 15 squared is 225. When we do the algebra, we do first x times x is x squared. Outsides, that's 9x. Insides is another 9x. And last is 81. We'll collect these two like terms. So we have x squared plus 18x plus 81 equals x squared plus 225. And I can see that I can subtract an x squared on both sides. Now that's a very nice thing, because when I do that, the x squareds are all gone. 18x plus 81 equals 225. We'll subtract the 81 on both sides, leaving 18x equals 144. Divide by 18, x works out to be 8. Now that was a little bit of a kind of deviation from the 3 previous types that we've done today, but it's something that does show up in this chapter, so we're once again going to have to be able to use that. Now we have a mixture of all the different types. So let's begin by identifying which type it is. This one is 2 chord segments. And to remind you, with chord segments, we take first part times second part equals first part times second part. And let's begin with the one that I've highlighted here in blue. If I take first part times second part, I'm going to take 9 times x. Then the one I'm highlighting here in yellow, first part times second part is going to be 3 times 6. And that's our setup. The rest of it is just going to be algebra. 9x equals 18. Divide by 9, x equals 2. And that's chord segments. Let's try another mixed one. First thing we try to consider here is, which type of problem is it? Well, as you can see, this one is secant segments. And to remind you, secant segments were when we took outside times the whole length equals outside times the whole length. And on these problems, I really encouraged you to label the whole length each time. So on the bottom one here, the one I've just highlighted in blue, we would like the whole length. That whole length is going to be when we take 5 plus x. Well, these two are like terms, so that's really 10 plus x. On the top one, the one I've highlighted here in yellow, the whole length would be when we add those together, which would be x plus 5 plus x. So that whole length would be 2x plus 5. There's the whole length on top. Here's the whole length on the bottom. Let's start out with the blue one. So for the blue one, the outside is 5, and the whole length was 10 plus x. For the yellow one, the outside was x, and the whole length was 2x plus 5. Now comes the algebra, distributing 50 plus 5x. On the right side, distributing 2x squared plus 5x. And you can see that we do have x's on both sides, but I think I can solve this one by using square roots. So what we're going to do is we're going to try to isolate the squared term. And that's because we're going to try to use square roots. We reviewed this technique again on the first week of this chapter. So I'm going to subtract the 5x on both sides. When we do that, we end up with 50 equals 2x squared. And then we'll divide by 2. We end up with x squared equals 25. And now we take the square root of both sides. If you remember from when we reviewed this, this gives us two answers. It gives us x equals positive 5 and x equals negative 5. Now in this problem, the negative one does not work. Now, unless you don't forget that the negative will never work, it will work in some problems in this chapter. So you do have to check that. We must box this answer or it is wrong. Do not forget that. Let's try one more example in this lesson. So when we look at this one, this is one of those where we have a secant segment and a tangent segment. We just did a secant segment 1, so we know that's where we take outside times whole length. And just to remind you, for the tangent segments, we only have an outside, so we take outside. Okay, sorry about that. Times outside. Okay, let's talk secant segment first. Here is our secant segment. As you've seen, we always want to know what the whole length is. So for the whole length here, we have to take the x plus 2 and add x, so we get 2x plus 2. Let's do that part of it first. The outside segment is x, and the whole length is 2x plus 2. For the tangent segment, the outside is 4, so 4 times 4. Now comes the algebra. 2x squared plus 2x equals 16. We'll subtract the 16 because it's a quadratic equation. Now this one does not factor. So since it doesn't factor, we're going to use the quadratic formula. Just to remind you, the quadratic formula is the negative b plus or minus the square root b squared minus 4ac all over 2 times the a. In our particular problem, we could divide by 2 to make all of the numbers smaller. Let's go ahead and do that. So we'll divide everything by 2 to make these numbers smaller. That gives us x squared plus x minus 8 equals 0. That would mean that the a is 1, the b is 1, and the c is negative 8. And now we'll go ahead and put it into that quadratic formula. So we would have x equals negative b plus or minus the square root, and then b squared minus 4 times a times c, all divided by 2 times the a. And we reviewed this again when we did that first week in the algebra review. Working out what's beneath the radical sign, we would have negative 1 plus or minus square root 33, all divided by 2. And this, of course, then splits into two possibilities. The possibility where we use the minus sign, x equals negative 1 minus the square root of 33 over 2, and where we use the positive sign, x equals negative 1 plus the square root of 33, all over 2. We're supposed to round here. It tells us we're rounding to the nearest tenth. So on the top one, we would get x equals negative 3.4. On the bottom one, we would get x equals 2.4. The negative 1, once again, will not work in this one because it gives us a negative length. So our answer is just x equals 2.4. Now look this last one over carefully. It did use the quadratic formula. If you need to go through it again, feel free to do that. I hope this section